So, are you familiar with the idea, the concept of rate limiting?
Um, I think so.
Okay, it's not a trick question. It's a just want to make sure you've kind of heard of that in terms of like software development. So, what we'd like to do today is build a rate limiter. So, something that will track usage for different users and let us know when that user is over some threshold of activity.
Okay. Um, okay. So, um, I guess my first question is how are we, like how it, so for in terms of like the user's activity, like does it, are we talking about like the, I guess, like are we saying like the amount of activity within an hour?
Yeah,
Does
so
it
that's a
like,
good question. I'll let you figure that out. Like activity within an hour, that makes sense.
okay.
We may end up building more than one rate limiter algorithm, depending on how good the first one is. Uh, so
Okay.
yeah.
Is whatever threshold we're setting just going to be like just some set threshold that's never going to change? Does it matter how many users there are? Like, like if we have a lot of users, do we want to set the threshold lower?
Yeah, that's interesting. As far as I'm aware, the thresholds for rate limiters are pretty static. It might be something
Okay.
that someone in a production scenario might be tuning themselves, but
Mm.
um, I'm not aware of any kind of like dynamic rate limiting. But that I'm sure that has been implemented somewhere.
Okay. Okay. And what exactly, so if they are of the threshold, do we just want to return a Boolean value? Like what do we actually want to do if they're, you know,
Yes, yeah. So we're just writing the rate limiter. So some function that'll return true if they're under the limit, and then false if they're over. That's all we got to do.
okay. So we want to watch a stream of activity, right? Like of continuous activity.
Yeah, exactly.
Okay. Um, hmm. Okay. Um, all right. So, so say, um, okay, I guess I'm trying to think this through. So, like, well, we need something that's observing the amount of activity they're doing. Um, and that activity is going to need to be connected to some kind of timestamp. And um, I'm trying to think like, so depending on how we do I guess like determine like the threshold for activity, do we want to just like, do we just want to get rid of, do we want to just not track the activity that's past the certain limit? So like if it's an hour, just ignore any activity that's more than an hour before. Um, okay.
So you're trying to figure out how you want to, like, what kind of memory, what do you want to hold on to in memory? Is that what you're thinking
Yeah,
through?
yeah, I'm thinking like, does it make sense to do it like, I'm sure like like, do we set up a dictionary and then we have like the timestamp and then we'll like the amount of activity at that timestamp for that's being watched, and then anything that's past an hour, just remove it from the dictionary.
That makes sense. I would advise against recording the timestamp for every event.
Yeah.
But yeah, what you're talking about, makes sense. And there's also like more than one solution. Let's
Sure.
Yeah, let's
So, okay, so if we don't need if we don't need the timestamp for every event, but we do need to know if it's like the activity is like within the hour or something, right? Because we're not just going to hold on to everything. I guess what we can do is the moment so we could just have timestamps on every hour, and then if it's within the hour, just record that event under that timestamp. Or what else could we do?
So you're also really only concerned with the latest hour, right?
Yeah. So I guess all we need to do is just record when they start doing events, and then we can, if any of the events are within an hour of it, then we'll keep it, and then I guess. So say like it's past an hour for then the first event got recorded, and I'm just trying to think, do we so when we're doing the rate limiter, do we just have it so that it measures that amount of activity for that hour, and then on the next hour that's like a whole new thing? Or do we do it like is it rolling? Does that make sense?
Yeah, so you could have like a rolling window. That's actually the term that's used.
Okay.
That's for you to figure out. There's trade-offs between algorithmic complexity and ease of implementation, and yeah.
Okay. I'm thinking. So if I don't do a rolling window, and I just have it so that on the hour that's a whole new window, and then the next hour it's a whole new window, that simplifies things a little bit. But that's not that can be kind of that might seem a little unfair, depending on how that's, I guess, on the user side, depending on how their activity is kind of distributed out within the hour. But a rolling hour, it'll, I don't know. Okay. If you pass the quick spike in activity, that might make a little bit more sense. Okay. Now I'm trying to think what it would have to do for the rolling window and how much harder that would be to code up. Okay. This might be a little annoying in Swift because of date objects, but all right.
Yeah, we can just do numbers and pretend they're millisecond timestamps.
Sure. Okay. All right. So I'm trying to think. So we could have it so that we could create just this class of the user's activity, some kind of dictionary, and then have functions that listen, like a function that listens into events and then adds it to some kind of timestamp dictionary, and then have a separate function that actually determines whether or not you're over the threshold. Okay. Let me, I guess, try to start modeling it out Um, mm, crap. Let's just hmm. For a rolling window, maybe it might make sense to, instead of a dictionary, maybe there's a way to like implement a heap and then sort the heap based on the earliest event, and then just check if that earliest event is within that hour-long window. And if it isn't, then just pop that event off.
Okay.
Yeah.
So why is an object not not an object? Why is like a dictionary not sufficient?
I guess so. With the dictionary, it's going to be like, I guess if I'm just storing like the timestamp or whatever, I don't constantly have to be searching for whatever the earliest event is, and then remove it and pop it off, and that's going to be like an O event operation every time I look for it. But if I do a heap, it's just going to be, it's an O of one operation to pop off the top one, and then log n to just kind of shuffle everything back around. And I feel like that might be better in the long run.
So if we're doing a rolling window rate limiter, I think you can simplify your approach here. I don't think you need a heap.
Okay.
Yeah.
Guess I could just do an array of events maybe then.
So you don't even need an array of events. So you could, if you tracked the number of events that a user has performed every hour, you could just asynchronously empty that object, right?
Oh,
just reset
yeah,
it for everyone.
and then just remove it for that hour.
Yeah.
Okay. All right. But if I was doing it so that like if that hour like moved as, I guess, like,
yeah,
you just track it from each hour, then
tracking it from the first event. Yeah.
Yeah, and then that's going to need like something a little bit more complicated.
Yeah.
Yeah. Okay. So I'll just treat it like a rolling window first. Let's just call this, I guess, events. I'm not even sure what type it'll be. Or can I just say that we're treating it like a int or something, and that for like each, like, this is kind of like a real oversimplification, but like if each event is we just treat it as like the quantity or the variable, I guess, we're trying to limit is just the number of events, not necessarily like the amount of like the actual, I don't know.
Right. Yeah. So yeah, not every event it's possible that different events might be of like different costs. It's kind of what you're getting at. Yeah. So all events are the same for now.
Okay. So if I'm just doing a rolling window, then I don't know, like, can I just say func watch activity is like is just this observer that watches events?
Yeah, if you can, if in the same coder pad we can send events off to it.
Okay.
You could also just call it directly with the time stamp.
Yeah, sure. Okay, and then we'll just say events one. All right. Okay. And then I don't know, we'll just call it 5 for now. And then we also need something that records the hour, I guess. So just call it window int, just say 0. Okay. And then if, okay. So if timestamp is, okay, plus, all right, if timestamp minus an hour or if window plus 1 hour, all right, so, I just call it 60 is if window plus 60 is greater than or equal to timestamp. So. And I can just bump up events by 1. Else, we're just going to update our window. And then maybe just do window plus equal 60. This isn't really like at all how like a timestamp or hours would work.
Sure.
Yeah, but
yeah, I mean, this all translates well. If
sure.
we're
And
just
then,
giving
and
it
then,
milliseconds, that's fine.
Yeah, and then we'll just say events. It gets translated. We'll reset to 0 and then add 1. So, and then here we'll just say if events is greater than threshold, or actually, I could just simplify this. Return events. Great. Okay, so, and yeah. So for this, you would just call watch activity at a timestamp every time an event occurs. And then it will check if the window that was set before plus 60 is greater than or equal to the current timestamp. You're going to bump events 1. Otherwise, you're going to move your window and then reset your events and then add 1. And then when you check if it's under your threshold, you check if events is less than or equal to your threshold. And then it'll return true if it's the number of events is less than the number of events that you set as a limit to. Otherwise, it'll return false, and then you're over the threshold.
Okay. Yeah, so this all makes sense. Can we write some test code for this?
Yeah, sure. Okay. Let equals user. Okay, and then One, 2, 3, 4, 5, and then check. Let's just print under threshold, and then do again. And let's print under threshold, and then let's let me make it. Okay, wait. So, and then I want to try it for the case where 61, and then Whoops, my mistake.
Yep.
Oh,
There you go.
Sorry.
I don't see any output.
Uh, hmm.
Do you need to invoke this, or does Swift handle this correctly? Does it call under threshold there, or is it trying to maybe like print out the reference to the function?
I thought it should just print out its output, but
I'm not familiar with Swift, so I don't know.
let me double check. Oh, there we go.
Okay.
Okay, first one should return true. Second one should return false. Third one should return true.
Okay.
Okay.
So can you think of any ways to break this code?
To break this code?
Yeah.
Well, if you can start messing with the timestamps, there's an issue.
So yeah. So assuming the values are not ever going down.
Yeah, like there isn't a situation where somehow like it's receiving an event previously, like it's
Yeah, so let's not worry about that case. Let's assume no time travel.
Okay.
Although that actually is something that you might have to consider in the real world if you're
like if there's an asynchronous call and then for some reason like an event arrives really late, but it was sent a while ago.
Yeah, or like if you have like multiple machines and they have different internal clocks, then maybe they're reporting. Yeah. So, but on one machine with the timestamp never going down, there is an issue with this code.
I think it's somewhere here. So it's just going to set the window plus 60. Wait, let me think.
Any ideas? Because you're on the right track. That line is definitely funny.
Yeah, I'm thinking.
So I can write a test case that'll break your code, and maybe that'll help you see what's going on. Yeah.
Oh, so if I get like an event 1,000, I probably just want to move the window to the timestamp instead of like the not. Yeah. All right.
Yeah.
So instead, let's just set it equal to the timestamp.
Easy.
Oops, sorry. Oops, sorry. Okay.
Cool. So that does it. All right. So right now, you wrote this to only handle this for an individual user.
Yeah.
So if you wanted to use this in some real world application where you have more than one user, how would you go about changing this code? And we don't necessarily have to write the code. We can talk about it for now.
So either I have like either I have user activity for each person or whatever,
Mm-hmm.
or I could just do it so that there's some kind of dictionary where that ties a user to the number of events they've received, and then maybe also have it so that you include the user's window is included in that dictionary.
Mm-hmm.
So watch activity would just check against that user's activity, same with under threshold. Yeah.
Okay. Yeah, so that makes a lot of sense. Yeah, I see two main approaches. One is you just use multiple user activities, and the other is you modify user activity to track multiple users. So like, what's the trade-off between those two approaches?
Um, I mean, if multiple instances of user activity, I don't have to rewrite that much code, but
Mm-hmm.
I'm also kind of, I might be, so I'll be duplicating like multiple instances of threshold when in reality, like everyone should have the same threshold, or at least in our version they do.
Mm-hmm.
We're not prioritizing one person's traffic over the other, although I don't know, maybe we would want to for some reason. Like, it's like a Netflix or something that uses a lot of data. Um,
Yeah, maybe users are tiered. That's interesting.
yeah. Okay. And if I do it as a dictionary, let me think. I guess part of it, the question is like, I don't know, like maybe we want everyone's window to roll over at the same time, right? Maybe we don't want to just track it from like that user's first event. Maybe we want to track it we want the window to update as everyone goes along.
Yeah. Yeah, I think for this specific rate limiter, having just one rolling window for everyone makes sense. What about like memory usage? Does memory usage differ between the two approaches?
I mean, in both cases, it's going to expand as, like for each user. Um,
Mm-hmm.
but, like if we a dictionary, we're probably just storing, like some kind of user ID to an event with a timestamp, which should be pretty cheap rather than having to create a whole instance of user activity for each person.
Right. Yeah, yeah, you would definitely have enough memory on your machine, but it's nice to use less memory when you can. So yeah, I think I see kind of that as the main performance trade-off, just the memory used. Cool. So you were actually touching on some interesting ideas for other kinds of rate limiters, and I think you were touching on how this specific approach can be unfair, where say you hit the limit and then all of a sudden you're blocked for an hour from using the service. So
Mhm.
can you conceive of perhaps like a more intelligent rate limiter that has the same end result but is maybe a little more forgiving or fair, or however you want to think about it?
Yeah. So we want to. Okay. Let me think how this would be adjusted, because somehow we want it so that, like, like if your first event, like you have a lot of activity for the first 5 minutes and then not a lot of activity, after that, like an hour later, you might get locked, but then 5 minutes pass and then it should reopen. So, I talked about the heap before, but the problem with that would be, um, we're potentially storing each event in
Yeah,
that.
yeah. So,
Although,
so, so,
yeah,
so I'll give you, maybe I'll help constrain the potential solution a little bit more. So
yeah,
you can a more ideal rate limiter, and kind of the way that we've been describing it, because this rate limiter that you wrote is perfectly valid for lots of applications, but one that's a little more
mm,
fair and doesn't block you for quite as long if you hit the rate limit. You don't really need to hold on to a lot more things in memory. It's really just kind of a different algorithm.
Yeah.
So you don't need a heap or anything fancy like that still.
Okay. I mean, we could just have it. Let me think. Can you just, maybe it's just the way we look at the window. Can we make the window update more frequently?
So that's one idea. But if we have a smaller window, then maybe say imagine then maybe your threshold would have to be smaller, so maybe it's easier to hit that threshold. If that makes sense.
Mm-hmm. Yeah. Okay.
So you're coming up with some interesting ideas. I'll help point you in the right direction, because it might be kind of hard to conceive of the exact one that I'm thinking of. But if we kind of flip this around a little bit and imagine you have this kind of budget of events per user that a user can spend, and say every 1 second you get one more token that you can make an event. You can make a request. And then if you have a maximum and then a minimum number of tokens that you can have. Does that make sense?
I see. Okay. So we introduce, so we have threshold here, but we actually we'll have like the number of tokens they can get. And then, if it's within like an hour or something, every 12 minutes they get a new token.
Mm-hmm.
And then I'm trying to think how. Okay, and then it'll eventually just reach a threshold. I'm just trying to imagine how like events should change.
What do you mean how events should change?
Or like at some point, events needs to like reset because we're not letting tokens pass a certain threshold. Although, so I guess what you could do is, because you give them tokens, then you remove the token when it sees an event.
Mm-hmm.
Okay. Okay. So, okay. So we need some kind of function to, function token. This function needs to get fired off, depending on however, I don't know how many times we need to do it. And then if tokens is less than threshold, tokens plus equals 1. Otherwise, do nothing. And then in here, so what we will do is check if the token is, we're going to remove a token if it's greater than 0. Otherwise, it's just going to, they'll be over the threshold. So if tokens is greater than 0, if minus equals 1, okay. Otherwise, we shouldn't let them proceed, I guess. I don't know. Sorry, I'm thinking, I just kind of like wrap watch activity with the checking if it's over threshold. Something, because if they're out of tokens, then you should probably just fire off that they're over the threshold. Because we don't currently I don't have timestamp right now.
You mean when you call this under threshold function?
Yeah. I guess like when you call like watch activity and it's decreasing the tokens as events fire off. If it ever checks that you're at 0, then it should probably just return false right there. I don't really need to like a separate function.
Yeah, yeah.
So turn, like I'll do return true if it's under the threshold like before, and then otherwise return false. And then that should be them not being allowed to continue. Do I need to do something to show how like the add token is being added? I guess as the time rolls on.
Well, yeah, we need to increase the number of tokens at some point. Otherwise, the user will never be able to use us again.
Okay. I could check. Okay. So in watch activity, maybe I can check the timestamp and see if it's I don't know, in this case, you can. We said before, like maybe every 12 minutes. So maybe you just check if it's divisible by 12. And then if so, then we add token. But we would actually have to like, I don't know, take the minutes of the timestamp or something and check if it's, I don't know, at a certain point.
Makes sense.
But let's say if timestamp. Wait, no.
Yeah, so that's the right idea, but the
that's not right.
specifics are a little off.
Okay, wait. I need it to like constantly update every 12 minutes. Maybe I can just have. Maybe I just have it so that the window. Okay, so maybe if I check if the window plus 12 times are. So if the window plus 12 is greater than the timestamp, give them however many tokens they're owed.
Makes sense, right?
Yeah. Okay. If all right, window plus 12 is. Okay, but I can't just add one timestamp. It'll have to be for however many, I don't know. Okay, I don't think this is doing some really basic math here, but I just want to check timestamp minus window divided by 12 is equals timestamp minus window divided by 12. Okay, sure. This feels like maybe unnecessary with like some of this function stuff, because then I could just check. Sorry, let me think. So if it's been like 30 minutes, they're owed 2 tokens. 2, 0, 1, add token, and it should stop if they're not that. Okay. I don't think I need, okay. Otherwise, okay, so after add token, I need to update the window. Okay. I think that should update the window, assuming, and this is just for the case where we're giving them tokens every 12 minutes.
Right.
Which is...
Yeah, so that's a little arbitrary, but so so there's still some more work that we need to do. So do you see anything missing in this algorithm? And there's also things that could be simplified. So we can,
this stuff is...
If you want to go about that in either direction.
Okay. I'll start by simplifying this logic here. Okay, let's just have it so tokens equals min of all right, and then then I don't really need this. Okay, so if there aren't any tokens available, return false. Okay, wait, so the user, we watch their activity, we take a timestamp of when an activity fires, we check if the window plus 12, let's just call this slip token rate equals, all right. Okay. Oh yeah, sorry. Okay, so now we don't need to. So we can just update token rate. So if the timestamp is currently greater than the window needed to get updated, then it's going to give them the number of tokens, either their number of tokens, or it's going to be set to what the threshold is, depending on what's smaller. And then it's going to update the window by the number of tokens and the token rate, and number of tokens should be okay. And then it checks if the tokens are greater than 0, that means they're not over their limit. We're going to decrease the number of tokens by 1 and then return true. Otherwise, their tokens are at 0, return false. Then what happens? The window should... All right, if the window's still up to date, then the next time they check, their tokens should go up, and then they should be able to do the activity.
Yeah, so this is pretty much there. A few issues potentially is right. So you touched on this earlier. This under threshold doesn't have a timestamp. So maybe you have some activity, and then we call this like an hour later. And we should be under the threshold, but we haven't updated events. But you can leave that alone for now. I'm sure you can handle that. Okay. And yeah, one more thing that we can simplify too is window. We can just set this to the timestamp, right?
Oh, sure. Yeah.
Yeah, it's just another little thing that you can make to make this more simple.
Okay.
But yeah, this is good. This is solid. Cool. All right, so that's the question. How do you think that went?
Obviously, I needed a little help coming up with like sometimes just breaking the code, um, and moving it from the rolling window to, I guess, something more fair. I'm not sure, honestly. Sometimes I just got tripped up trying to figure out like how I wanted to model things,
Mm-hmm.
and there were cases where I was maybe jumping around a bit too much and not being super clear with what I was thinking about.
Okay.
Yeah.
Yeah. So what I saw, I think you did a pretty good job of talking about like the different, well, coming up with a rate limiting algorithm, and then coming up with how that might be improved and potential issues with the original approach. So I think you did a really good job of that. I think you actually did a pretty good job too of explaining your thought process. The concern that I have is more around like kind of like the code style.
Yeah, cleanliness. Yeah.
Yeah. So yeah, the naming's pretty decent. I don't normally harp too much on naming in an interview, but there were some things initially where you had like a function that would add one token, and then in another place you had like n times add one.
Yeah, that was yeah.
Yeah, so that was I was surprised to see that. So there were a couple instances of code that like I wouldn't I kind of didn't want to see. Yeah, so what's a good way to describe that? Yeah, so these are kind of like bite-sized problems, and in like larger applications, you can introduce a lot of unnecessary complexity by kind of having this code that on a smaller level is already a little could be simplified. So I think seeing a few cases like that in a problem of this size is a concern for me. I know that you've done much better about that in the past. So knowing what I know now, that's not as much of a concern. But if I had just seen this one interview, this interview would be a fail, but like not a strong fail. That's really kind of the main issue that I saw. But there were a lot of good things that I saw too. So there was so it touched about the deriving the rolling window algorithm. You came up with a good test too. Like there were cases where you expected it to be true and false. So this was a good test. It would have been better if that was something that you kind of wrote out and you were testing this code as you were writing it. Yeah, and that's something that gets a lot of people too. And it's something that I actually surprisingly see very few people do. But it just gets you a lot of points if you kind of test your code as you're going, and I think it makes it easier for you on your own too.
Okay.
There's one other thing too that was I had down as kind of a minus, but then you later thought of it on your own, and that's really just kind of the design of like what should this interface to this rate limiting algorithm look like. And you originally came up with these two different functions which had that problem where like this under threshold doesn't consider the current timestamp.
Yeah.
But if this was combined into one function, then that would be okay. So that one's not as much of a concern. That's kind of a higher level gripe in terms of kind of like API design. So yeah, I think, a lot of good things. I just think there were some missteps in terms of the logic and kind of simplifying things as we go along. So what do you, does that make sense?
Yeah, makes a lot of sense.
Cool. Is that something that you feel like you did more of today in terms of like the unnecessary complexity? Because I haven't noticed that before, really.
Yeah, I think I tend to have that more when it's like when when some of the stuff was more like API design rather than I guess just a code for a single function, or
Okay.
not explicitly code for a single function. And I think it's something I maybe need to work on, just
Okay.
making sure that like everything's a lot cleaner and easier to read.
I have a idea of why that might be, but do you know why that? Can you think of why that might be happening?
Um, I mean, maybe part of it is just um, not being super clear about what the like end goal is, so it ends up being like creating a lot of different functions that accomplish a lot of like little things that get kind of loaded or
Hmm.
I'm not I don't I don't know. What do you think the issue might be?
I think that's really another way to say what I was thinking about. I guess with a question like this where I just give you a problem and you conceive of an algorithm and you conceive of an API and you code the algorithm. That's a kind of a lot more moving pieces than most interview questions. So I think it's really just a factor of like thinking about more things.
Yeah.
And then also, in interviews, like, you don't, it's kind of a question of like, how much time do I actually want to spend like refactoring my own code?
Yeah. Yeah.
So that kind of comes into play too. So I'm not sure that's something that everyone would have issue with, or at least as much issue that I have with. But I also want to give you like a accurate representation of how I think I would evaluate someone in the real world, with this just being the first time that we've done anything together.
Okay, of course.
Yeah. So that's really it. Cool. Yeah, I hope that was helpful. I think this is good. Just yeah. Main feedback is test your code and maybe once or twice, kind of as you're developing, think about like, is this like overly complicated? Can this be simplified? Because there's also kind of that same thing with your original idea of the rolling window, having like a separate rolling window for each, a separate like start of the rolling window for each user. And that's something that you could just have one timestamp for all of the users.
Yeah.
So yeah, that's something that's like really great to see. Like if someone comes up with a solution that's like as simple as possible, like that's like a fantastic thing. You might not always be there, but yeah, I mean, even though this I wouldn't consider this a passing interview. I think yeah, still you get there's a lot of good things here still.
Okay.
All right. Any other questions?
No, I don't think so right now.
All right. Well, thanks, Nigel.
All right. Thank you.
Yep. See ya.